In this lecture we find out the area of the green shape using two different methods. In the drawing we have three identical squares. We know that one side of a square is equal to 2 units in its length. In addition we have this green right angle. This is a right angle, and our task is to find out the area of this green shape, because actually we have to find out the area of this green right angle. So first of all, one side of this square is equal to 2, therefore all the other sides must be also equal to 2, because those are three identical squares. So all the sides of all the squares must be equal to 2 units in their lengths. In the next step, we invent the Cartesian system in our drawing. This will be the x-axis, this line, this is the positive side of x-axis, and this is the negative side. We define this straight line is y-axis, the upper side of y-axis is the positive side of y, and this is the lower side of y-axis is the negative side of y-axis. The intersection point between x-axis and y-axis is at this point. This point is defined as the origin, and the coordinates of the origin is 0, 0. So we define the origin of this Cartesian system as O. The coordinate x equals to 0, the coordinate y also equals to 0, because of the fact that this is the beginning point of both coordinates x and y. So what is the slope of this straight line? So first of all, we define, if letters the relevant points of this question. We define this point as point A. We define this point as point B. So what is the slope of the straight line BO? The slope of a straight line is the tangent of the angle that the straight line creates with the positive side of x-axis. So we are talking about this angle. The tangent of this angle is the slope of this straight line BO. This is a right angle, but what is the side of this angle? The diagonal, this diagonal of the square bisect the angles of the square. That is to say, the diagonal of the square bisects the angles of a square, so each angle equals to 90 degrees, and therefore each half must be equal to 45 degrees. This is the first half of the right angle, that is 45 degrees, and this is the second half, of this right angle is also 45 degrees inside. So this angle equals to 45 degrees inside. This is a right angle. So 45 degrees plus 9 degrees is 135 degrees. The slope of a straight line is defined as m. So the slope m of this straight line BO equals to the tangents of the angle that the straight line creates with the positive x-axis. That is to say, it is 45 degrees plus 9 degrees, that is 135 degrees. And again, the slope of this straight line BO is equal to tangent 135 degrees. So m equals to tangent 135 degrees, and tangent 135 degrees equals to minus 1. So the slope of the straight line BO is equal to minus 1. M equals to minus 1. Point O is located on the straight line BO, and the coordinate x is 0, coordinate y is 0. So the equation of this straight line BO will be equal to y minus y1 equals to m, that is the slope of this straight line, that is minus 1, times x minus x1. x1 and y1 is the point that we know the value of it. That is to say, it is point O. It's point O, the coordinate x equals to x1 and x1 equals to 0. And the coordinate y of this point O is also equals to 0. So the coordinate y is y1 and y1 equals to 0. So m is minus 1, so we just have to put the data of this straight line inside this general formula for a straight line, and this way we find out the equation of this straight line BO. So according to this formula, we have y minus y1. y1 is 0, so it is y minus 0 equals to m. M is minus 1. The slope of this straight line BO is minus 1. And inside the brackets we have x minus x1. x1 is 0, so it is x minus 0. So the equation of this straight line BO is as follows. Y minus 0 is y, and it is equals to minus 1, and x minus 0 is x. So y equals to minus 1 times x, that is minus x. So here y equals to minus x. The equation of this straight line BO is y equals to minus x. What is the slope? But before that, what are the coordinates of point A? This is the positive side of x-axis, and this is the negative side of x-axis. So the coordinate A and the coordinate x of point A will be equal to, from point 0 we have to move minus 2, minus 2, minus 2. In total it is minus 6. So the coordinate x of point A is minus 6. And what is the coordinate y of point B? This is one side of the square, that is 2. So this is point 2. So here it is also point 2. So the coordinate y of point A equals to 2. So the coordinate of point A is 1, 6 and 2, and the coordinate of the origin O is 0, 0. So we have 2 points. Both those 2 points are located at on the straight line AO. So those 2 points passes through the straight line AO. And therefore we can find out the slope of this straight line AO by using those 2 known 2 points. And the slope of the straight line AO it is equal to the slope of the straight line AO, M equals to y2 minus y1 over x2 minus x1. What is a slope? A slope of a straight line measures its steepness and direction, and it is calculated by the vertical change, that is actually y2 minus y1 over the horizontal change, that is x2 minus x1. Okay. So we define minus x as x2 and 2 as y2. Here we define the coordinates of point O, the coordinate x of point O, 0 as x1, and the coordinate y of point O as y1. Okay, so the slope of the straight line AO equals to M equals to y2 minus y1 over x2 minus x1. Actually, the slope of a straight line indicates how much the line goes up or down. If a straight line has a positive slope, this straight line has a positive slope, then the straight line goes up from the left side to the right side. If the slope of a straight line is negative, then the slope goes down from the left side to the right side. And if a slope of the straight line is 0, that is to say it is parallel to the x-axis, like this straight line, then it is it is parallel to the x-axis. It is if the slope of a straight line equals to 0, then it is parallel to the x-axis. You can see this straight line with slope 0 is parallel to this x-axis. And if a slope of a straight line is vertical, then it means that it doesn't have a slope at all. In this case, it's parallel to the y-axis. Then it means that it doesn't have a slope at all. So in conclusion, you can say that a positive slope goes up from the left side to the right side, and negative slope of a straight line is negative, then it goes down from the left side to the right side. And if the slope of a straight line is 0, then it is parallel to the x-axis. And if we are talking about a straight line that is parallel to y-axis, then it doesn't have a slope at all. Okay. So here the slope of the straight line BO is negative, it equals to -1, and therefore it goes down from the left side to the right side. Okay. So we find out the slope of this straight line AO. The slope of the straight line AO equals to, again, it is equals to the ratio between the vertical change, that is y2 minus 1, y2 minus y1, over the horizontal change, that is x2 minus x1. This is the ratio between the vertical change to the horizontal change. So y2 minus y1, y2 is 2, minus y1 is 0, so it is 2 minus 0 over x2 minus x1. x2 is minus 6, minus x1 is 0. So then we found out that the slope of the straight line AO equals to 2 minus 0 is 2, over minus 6 minus 0 is minus 6. 2 over minus 6 is minus third. So the slope of the straight line AO equals to minus third. You can see here the slope of the straight line AO is negative, therefore it goes down from the left side to the right side. So the slope of the straight line AO equals to minus 3. Here we can implement rule 12. Why? Because the straight line AB is perpendicular to the straight line AO. That is to say, at their intersection point, they make angle of 90 degrees. So those two straight lines perpendicular to each other. Therefore, whenever you have two lines that are perpendicular to each other, you can implement rule 12. So please quickly on rule 12. According to rule 12, if two lines intersect with each other at 90 degrees, like here, at the intersection point, they make 90 degrees, and we know that the slope of the first line is m1. The slope of this straight line is m1, and the slope of the second one is m2. Then the following equation is true. m1 times m2 equals to minus 1. Okay, m1 times m2 equals to minus 1. So we can implement the new formula in our drawing. In our drawing, so as I mentioned before, the straight line AB is perpendicular to the straight line AO. And whenever you have two straight lines that are perpendicular to each other, you can implement rule 12. We already found out that the slope of the straight line AO is 1/3. So we define the slope of the straight line AO is m1. The slope of the straight line AB is unknown, so we define the slope of this straight line AB is m2. And according to rule 12, the product, the multiplication of the two slopes for each other, that is associated minus 4 times m2 equals to minus 1. Again, the product of this, the multiplication of the two slopes for each other equals to minus 1. And again, m1 is minus 3 times m2 that is unknown. In total, it must be equal to minus 1 according to rule 12. Why? Because of the fact that those two straight lines perpendicular to each other. Here we multiply this equation by minus 1. So here minus times minus is plus. So in this side of the equation we have third. The slope of this straight line AO equals to minus 3. So we have minus 3 times m2. So after multiplying the equation by minus 1, here minus times minus is plus. So in this side of the equation we have m2 over 3 equals to minus 1 times minus 1 is 1. So in total we found out that m2 over 3 equals to 1. Here we multiply this equation by 3 and find that the slope of the straight line AB is equals to m2 is equal to 3 times 1 is 3. So the slope of this straight line AB equals to 3. M2 equals to 3. Point A is located on the straight line AB, therefore we can find out easily the equation of this straight line AB. Whenever you have the value of a slope and one point of a straight line, you can easily find out the equation of the straight line according to the following formula that I already presented to you. Y minus y1 equals to m times x minus x1. So we are talking about the equation of this straight line AB. We already found out that the slope of this straight line AB equals to 3. So m equals to 3. Point A is located on the straight line AB. So here x1 equals to minus 6. And y1 equals to 2. y1 equals to 2. So we just have to put the data of our straight line AB in the general formula for a straight line. In this way we find out the equation of this straight line AB. So we have here y minus y1. This is y minus y1, y1 is 2, equals to m is 3, and inside the brackets we have x minus x1. X minus x1. x1 is minus 6, and therefore x minus x1 equals to x minus 6. So we can find out that y minus 2 equals to 3 times x minus 6 is x plus 6. So in total we found out that y minus 2 equals to 3 times x plus 6. Here we open the brackets on this side of this the equation, and we get that y minus 2 equals to 3 times x is 3x, plus 3 times 6 is 18. So in total we found out that y minus 2 equals to 3x plus 18. Here we add 2 to this equation, and when we get that y equals to 3x plus 18 times 2 is 20. So the equation of the third line AB is y equals to 3x plus 20. The equation of this third line AB is y equals to 3x plus 20. And we already found out that the equation of the third line BO is y equals to minus x. Point B is a common point that belongs to both third lines. Point B belongs to the third line BO, and point B belongs also to the third line AB. And we have a rule that says that if a point is located on a third line, then it satisfies the equation of the third line. Again, you have the rule that says if a point is located on a third line, then it satisfies the equation of the third line. Point B is located on both third lines, and therefore point B must satisfy the equation of those two third lines. The equation of this third line BO is y equals to minus x, and the equation of the third line AB equals to y equals to 3x plus 20. So point B must satisfy the equations of those two third lines because of the fact that point B is located on both third lines. So we define the x coordinate of point B is x1, and we define the y coordinate of point B as y1. Because of the fact that point B must satisfy the equation of the third line AB, it means that we can substitute x by x1 and y by y1, and we get that the right side of the equation equals to the left side of the equation. That is the meaning that a point satisfied the equation of the third line. It means that if you substitute the coordinate x and y by the value of the coordinate of x and y of the point, then the left side of the equation will be equal to the right side of the equation. So we substitute x by x1 and y by y1 in this equation of the third line AB. So here y equals to y1, and it equals to 3x. X is x1, so it is 3x1 plus 20. So according to equation 1, we should find out that y1 equals to 3x1 plus 20. Likewise, because of the fact that point B is also located on the third line BO, therefore it must satisfy the equation of this third line BO. That is to say, we can substitute y by y1 and x by x1. This the equation of the third line BO. So we get that y is y1 equals to minus x. X is substitute x by x1. So in total, according to equation 2, if we found out that y equals to minus x1. Well, according to equation 1, again, y1 substitute y by y1. So in total, if we found out that according to equation 2, y1 equals to minus x1. Well, according to equation 1, we only found out that y1 equals to 3x1 plus 20. In the next step, we get equation 3 that says that y1 according to equation 1 must be equal to y1 according to equation 2. y1 according to equation 1 equals to 3x1 plus 20. And it must be equal to y1 according to equation 2. y1 according to equation 2 equals to minus x1. So to that, we found out that according to equation 3, 3x1 plus 20 equals to minus x1. And again, according to equation 3, we found out that 3x1 plus 20 equals to minus x1. Here we add x1 to this equation, equation 3, and we get that 3x1 plus x1 is 4x1, so it is 4x1 plus 20 equals to 0. Here we subtract 20 for this equation, equation 3, and we get that according to equation 3, 4x1 equals to minus 20. Here we divide this equation 3 by 4. And we get that 4x1 over 4 is x1 equals to minus 20 over 4 is minus 5. So x1 equals to minus 5. So if you found out that the coordinate x of the point B equals to minus 5, what about the coordinate y of point B? It is y1. And according to equation 2, y1 equals to minus x1. So y1 equals to minus x1, and x1 is minus 5. So in total, according to equation 2, y1 equals to minus 5. Minus 5 is 5. So y1 equals to 5. y1 equals to 5, that is to say, the coordinate y of the coordinate y of point B equals to 5. So we found out both coordinates of point B. It is minus 5 and 5. Now we will calculate the distance between points A and B. We calculate the distance between points A and O. The distance between points A and B is the length of side AB, while the distance between the 2 points A and O is the length of side AO. And the area of the green shape is the area of this green right triangle. We know that the area of green triangle equals to the base of the triangle times the height over 2. we know the length of AB, that is the distance between points A and B, times the length of side AO, that is the distance between points A and O, divided by 2. This will be the area of the green triangle, that is also the area of the green shape. Okay? So first of all, what is the formula that gives us the distance between 2 points? So what is the distance between points Q and P? The coordinates of point Q as follows. The coordinate x of point Q is x2, and the coordinate y of point Q is y2. Likewise, the coordinates of x of point P is x1, and the coordinate y of point P is y1. So the green triangle is a right triangle. This is a right angle. And you know that according to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this green right triangle QPO, QP squared, that is the square of the hypotenuse, equals to QR squared plus RP squared. Repeat again, according to the Pythagoras theorem, in this green right triangle PQR, PQ squared, that is the square of the hypotenuse, equals to PR squared plus QR squared. So PQ is the unknown hypotenuse, so relativity, so it is PQ squared equals to PR squared. What is the length of PR? PR equals to x2 minus x1. Again, PR equals to x2 minus x1, therefore PR squared must be equal to x2 minus x1 squared. And we have plus QR squared. What is the length of QR? QR equals to y2 minus y1, and therefore QR squared must be equal to y2 minus y1 squared. So today we found out that PQ squared equals to x2 minus x1 squared plus y2 minus y1 squared. So here we take a look at this equation and found out that PQ, the length of the hypotenuse PQ, is equal to the square root of x2 minus x squared, x2 minus x1 squared, plus y2 minus y1 squared. The length of the hypotenuse PQ is definitely also the distance between points Q and P. The length of the hypotenuse QP is the distance between points Q and P. So this equation gives us the distance between any two points, because points Q and P could be any points. If you take 2 points, you create a right triangle like this, and you calculate the length of the hypotenuse according to the Pythagoras theorem, and the length of the hypotenuse is the distance between the 2 points. The equation is PQ equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we use the new formula in order to find out the distance between those 2 points A and B. So according to the new formula, the distance between points A and B, actually also the left of side AB of the green triangle BO. So the distance between points A and B, according to the new formula, equals to the square root of x2 minus x1 squared plus y2 minus y1 squared. So AB equals to the square root of x2 minus x1 squared. Here we have, so we define the coordinate of x of this point B as x2, and x2 equals to minus 5, and the coordinate y is y2, and y2 equals to 5. Likewise, we define the coordinate x of point A as x2, it's x1, and the coordinate y of point A is y1. So x2 plus x1 square equals to minus 5 minus 6. Minus 5 minus 6 is minus 5 plus 6, and minus 5 plus 6 is 1, and 1 square is 1. So in total, if we found out that x2 minus x1 square equals to 1 square, this is 1, plus y2 minus y1 square. y2 is 5, minus y1 is 2, so 5 minus 2 is 3, and 3 square is 9. So in total, we found out that y2 minus y1 square equals to 3 square, which is 9. So in total, AB equals to 1 plus 9 is 10, so it is square root of 10. And again, the distance between points A and B is also the length of side AB, or the right triangle ABO. So the length of side AB is square root of 10 units. So it is known side AB equals to the square root of 10 units in its length. In the next step, we calculate the distance between points A and O. That's actually the length of side AO of the right triangle ABO. So according to the new formula, the distance between points A and O is equal to the square root of x2 minus x1 square plus y2 minus y1 square. So AO equals to the square root of we choose the coordinate x of this point A is x2, and the coordinate y is y2. Likewise, we define the coordinate x of this point O is x1, and the coordinate y of this point O is y1. So according to the new formula, AO, the distance between points A and O, is equal to the square root of x2 minus x1 square. x2 is minus 6, that is plus 6, minus x1 is 0, so 6 minus 0 is 6, and 6 squared is 36. So in total, we found out that x2 minus x1 squared equals to 36 plus y2 minus y1 squared. y2 is 2 minus y1 is 0, so 2 minus 0 is 2, and 2 squared is 4. So we found out that y2 minus y1 squared equals to 4. So we found out that the distance between points A and O, that is also the length of right side AO, is equal to the square root of 36 plus 4 is 40. So this the distance between points A and O is also the length of side AO of the right triangle ABO is equal to the square root of 40 units. Our task is to find out the area of this green shape. So what is the area of the green shape? The green shape is actually the green right triangle BAO. So our task is actually to find out the area of this green right triangle BAO. And again, because of the fact that the green shape is the green triangle ABO, our task is to find out the area of the green triangle BAO. You know that the area of any triangle equals to the base of the triangle times the height over 2. We choose the base of this green triangle as AB, and the height is AO. Why the height is AO? Because it's green triangle with the base AB divided by 2. So in total, we found out that the area of the green shape equals to the base AB of the green triangle ABO times the height that is AO over 2. We already found out that AB equals to the square root of 10 and AO equals to the square root of 40. But again, AB equals to the square root of 10 and AO equals to the square root of 40 divided by 2. The square root of 10 times the square root of 40 is the square root of 400 over 2. The square root of 400 is 20 and 20 over 2 is 10. So if we found out that the area of this shape, that is the area that we are looking for this question, in total it is equal to 10 square units in its size. And again, if we found out that the area of this green shape equals to 10 square units in its size. So we finish with the first method. In the next step I will present to you how to find out the area of this green shape according to the second method. We know that we have 3 identical squares. The side of one square equals to 2, therefore all the other sides are also equal to 2 because they are identical. All the angles here are right angles. So this is a right angle, this is a right angle. Those two angles are also right angles. So in this big quadrilateral we have 4 right angles. Therefore this big quadrilateral is a right angle. We also know that the opposite sides of right angle are equal to each other. the opposite sides of rectangle are parallel to each other. So in this big rectangle, those two opposite sides are parallel to each other. And you extend two parallel sides by a straight line, the result must be also, the extended sides must be also parallel to each other. So we extend those two parallel sides by a straight line. The extended straight line must be also parallel to each other. Those two extended sides. In the next step, we will create a perpendicular on this straight line in such a way that it will pass for this vertex. The vertex of the right triangle. This is a right triangle according to our construction. We do perpendicular on this side, therefore it is a right triangle according to our construction. This is a right triangle because it is a square. This is also a right triangle because it is a square. We define this big quadrangle, the vertex with the vertices of this big quadrangle. So by doing these constructions, we create the big quadrangle ABCD. Inside this big quadrangle ABCD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. 270 degrees plus the size of this 4 piece angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that says that the sum of the angles in any quadrangle is equal to 360 degrees. Therefore, this 4 piece angle must be equal to 9 degrees inside. Another reason that this 4th missing angle must be equal to 9 degrees inside is because of the fact that those two straight lines are parallel to each other. This angle equals to 9 degrees. So those two angles that are defined as one-sided interangles are located between the parallel lines AD and BC. And we know that the sum of two one-sided interangles between parallel lines is equal to 180 degrees. Okay? Those two one-sided interangles are located between the parallel lines AD and BC. And we have the rule that says that the sum of two one-sided interangles is equal to 180 degrees. But this is a right angle according to our construction. So 9 degrees plus this missing side must be equal to 180 degrees according to the rule that I mentioned. Therefore, this 4 and this missing angle must be equal to 9 degrees inside. So I give you two reasons that this 4th missing angle must be equal to 9 degrees inside. Okay. So in the next step, we will define this angle as angle alpha. And we define this point, it's point E. If AD is one side of rectangle ABCD, again, ABCD, quadrangle ABCD is 4 right angles, and we can relate to quadrangle ABCD is a rectangle. because it has 4 right angles. The big quadrangle ABCD is rectangle because it has 4 right angles. So AD is one side of rectangle ABCD, therefore it is absolutely a straight line. So if you focus on the right side of the straight line AD, it's point D. Here the sum of the angles must be equal to 180 degrees according to Rule 3. Rule 3 said that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of the straight line AD, it's point D. We have alpha plus 90 degrees plus this third missing angle, total must be equal to 180 degrees according to Rule 3. So it is known. So the right side of the straight line AD at point E, the sum of the angles must be equal to 180 degrees according to Rule 3. That is to say, alpha plus 90 degrees plus this third missing angle, that is the angle AE, we define this point as F, plus this missing angle, the angle AEF. In total, the sum of those 3 angles must be equal to 180 degrees according to Rule 3. Repeat again. If you focus on at the right side of the straight line AD at point E, the sum of the angles must be equal to 180 degrees. So which angles we have at the right side of the straight line AD at point E? We have alpha plus 90 degrees plus the first missing angle AF. In total must be equal to 180 degrees according to Rule 3. So here we subtract 90 degrees from this equation. And you get that alpha plus the missing angle AEF is equal to 180 degrees minus 90 degrees, it is 90 degrees. So here we subtract alpha for this equation, and here you get that the missing angle AEF is equal to 90 degrees minus alpha. So here, this is the missing angle AF, this is equal to 90 degrees minus alpha. So in this right triangle AFE, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees, and therefore this first angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in a triangle. Likewise, in this lower right triangle EDC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha according to the sum of the set, that the sum of the angles in a triangle is equal to 180 degrees. It's very easy to see that those two right angles are similar to each other according to angle similarity rule. So right triangle AFE is similar to this right triangle EDC. First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, and therefore they are equal to each other. So if you found out that all the angles of this upper right triangle AFE corresponding equal to all the figures of this right lower triangle EDC, and therefore those two right triangles are similar to each other according to angle similarity rule. So write it down. And we found out that this is the green right triangle AFE. It is similar. This is the sign of similar to this right lower triangle EDC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side AE of this upper right triangle AEF over side DC of this right lower triangle EDC is equal to side AE of this upper right triangle. This is actually AF. Is equal to AF of this upper right triangle AFE over ED over ED. And again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AE of the upper right triangle AFE or side DC of the right lower triangle EDC, it is equal to side AF of the upper right triangle AFE over side ED of the right lower triangle EDC. AE is the missing side, so we leave it as it is over DC. DC in total equals to 2 plus 2 plus 2, that is 6. And it's equals to AF. AF is the missing side, so we leave it as it is over ED. ED equals to 2, according to what is given in the question. So, in total, we actually found that AE over 6 equals to AF over 2. Here we cross multiply this equation, and here you get that 2 times AF equals to 2 times AE. AE equals to 6 times AF. And again, if you found out that 2 times AE equals to 6 times AF. Here we divide this equation by 2. So we get that AE equals to 3 times AF. If we define the length of side AF as x, then according to this equation, AE must be equal to 3x. And AE equals to 3x. So here, if we define AF as x, then AE must be equal to 3x. Equals to 3x. We know that the opposite sides of a rectangle are equal to each other. So in the big rectangle ABCD, side AB must be equal to the opposite side DC. Now, in the big rectangle ABCD, the opposite sides are equal to each other. That is to say, side AB equals to the opposite side DC. But DC equals to 2 plus 2 plus 2, this is 6. So we can write here that DC equals to 6. And for this equation, AB equals to DC equals to 6. We derive that AB must be also equal to 6 units in its length. AB equals to 6. So what is the length of this line segment FB? From the drawing, it is very easy to see that FB in total equals to AB minus AF. And again, from the drawing, it is very easy to see that FB equals to AB minus AF. So FB equals to AB 36, when we found out that AB equals to 6, according to the rule that the opposite sides of a rectangle are equal to each other, and AF equals to x. So F equals to AB and AB equals to 6, minus AF is equals to x. So in total, if you found out that FB equals to 6 minus x units in its length. This is side FB that equals to 6 minus x units in its length. According to the same rule that the opposite sides of a rectangle are equal to each other, so in the big rectangle ABCD, side AD must be equal to the opposite side BC. But AD in total equals to 3x plus 2, therefore the opposite side BC must be also equal to 3x plus 2 units in its length. So the opposite side BC, ABCD, equals to 3x plus 2 units in its length. BC equals to 3x plus 2 units. We know that the diagonals of a square bisect the angle of the square. So in this square, this diagonal bisects this angle. That is to say, it divides the right angle into two halves. The first half is 45 degrees, and the second half is also 45 degrees. So in this big right triangle ABC, this angle equals to 45 degrees. This angle equals to 90 degrees. 45 degrees plus 90 degrees, it is 135 degrees. 135 degrees plus this BC angle, so they must be equal to 180 degrees according to the rule that said that the sum of the angles in any triangle is equal to 180 degrees. And therefore, this first BC angle must be equal to 45 degrees in size. we have the rule that says that in front of equal angles in the triangle they are equal size. So in the big triangle FBC, in front of those two equal angles, we have those two sides that must be also equal to each other and their lengths. That is to say, side FB equals to side BC. FB equals to BC according to the rule that I mentioned. But we already found out that FB equals to 6 minus x. So I can write here that FB equals to 6 minus x. And from this equation, 6 minus x equals to FB equals to BC. We write that BC must be also equal to 6 minus x units in its length. So from one side, BC equals to 3x plus 2. From the other side, BC also equals to 6 minus x. From this equation, those two sides of the equation are equal to each other. That is to say, 3x plus 2 equals to 6 minus x. Here we will add x to this equation. If we get that 3x plus x is 4x, plus 2 equals to 6. Here we subtract 2 from this equation. If I get that 4x equals to 4, here we divide this equation by 4. If I get that x equals to 1 unit in its length. AF equals to x and x equals to 1, therefore AF also equals to 1, of course. Likewise, AE equals to 3x and x equals to 1, therefore A equals to 3 times 1, that is 3. The length of side AE is 3 units. The length of side AF is 1 unit. So in the next step, we implement the Pythagoras theorem on this right triangle FAE. In the right triangle FAE, here by PT is a version for Pythagoras theorem. So in this right triangle AFE, the square of the hypotenuse FE squared, according to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse of this in this right upper triangle AFE is FE, so the square of the hypotenuse is FE squared. Equals to AF squared, that is 1 squared is 1, plus AE squared. A is 3, therefore A squared is 3 squared, that is 9. So in total, we should found out that FE squared equals to 1 plus 9, that is 10. So FE squared equals to 10. Here we take out of the equation. If I get that the missing hypotenuse FE is equal to the square of 10 units in its length. This is the hypotenuse FE is equal to the square of 10 units in its length. Likewise, we implement the Pythagoras theorem on this right lower triangle, triangle EDC. The right lower triangle, triangle EDC. The square of the hypotenuse is EC squared. And EC equals to 2 squared, that is 4, plus DC squared. DC is 6, therefore DC squared is 6 squared, that is 36. So in total, we should find out that EC squared equals to 4 plus 36, that is 40. EC square equals to 40. Here we take root of the equation and find out that the missing hypotenuse AC is equals to the square root of 40 units in its length. This is the missing hypotenuse AC is equals to the square root of 40 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? The green shape is the green right FEC. So actually our task is to find out the area of this green right FEC. And again, because of the fact that the green shape is the right triangle FEC, our task is to find out the area of the green right triangle FEC. We know that the area of any triangle equals to the base of the triangle times the height over 2. We choose the base of this green right triangle FEC, SFE, times the height, that is EC. Why? Because EC creates 90 degrees with the base FE. This angle equals to 90 degrees. So the height is EC over 2. So we found out that the area of the green shape equals to the base FE times the height EC over 2. We already found out that FE equals to the square root of 10 and EC equals to the square root of 40. So FE times EC is equals to the square root of 10 times the square root of 40 over 2. The square root of 10 times the square root of 40 is the square root of 400 over 2. The square root of 400 is 20 and 20 over 2 is 10. So the area of the green shape is equal to 10 square units in its size according to both methods. Okay, again, we should find out that on both methods the area of this green shape is equal to 10 square units in size. So finished with the second method. So in the next step, I'll start the lecture. We start with the first method, of course. In this question, our task is to find out the area of this shaded area, the area of this green shape. Okay, so in the drawing we have three identical squares. We know that the roof of one side of the square is 2, therefore all the sides must be also equal to 2 because they are identical. In addition, we have here the right ventral ABO, and our test is to find out the area of this right triangle and ABO. So first of all, we define the Cartesian system in our drawing. That is to say, we define this straight line as x-axis and define this straight line as y-axis. This is the positive side of x-axis and this is the negative side. Likewise, this is the positive side of y-axis and this is the negative side of y-axis. The intersection point between y-axis and x-axis is at this point. This point is defined as the origin. This is to say it is the starting point of the x-axis and y-axis. Therefore, if we define the origin point, this point is point O, then the x coordinate, likewise the y coordinate, they are both must be equal to 0 because the origin is the starting point of both coordinates. So the coordinates of point O, the origin is 0, 0. Okay, this is to say the coordinate x is 0 and the coordinate y on this straight line O is also 0. So once we define this point as point A and define this point, that is the vertex of this green right triangle, this point is point B. What are the coordinates on this point A? As I mentioned before, this is the negative side of x-axis. So for point 0, we move left 2 steps and 2 steps more and 2 steps more. So in total, we moved 6 steps to the left side. Therefore, the coordinate x, that is the negative side of x-axis. Therefore, the coordinate x must be equal to minus 6. And what about the y coordinate of this point A? The length of this side of this square is 2. So this is point 2 of the y coordinate, exactly like this point. This is also point 2. So the y coordinates of point A is 2. So in total, the coordinates of point A are minus 6 and 2. Point B is unknown, we don't know the coordinates of point B, so we define the coordinate x as x1 and the coordinate y of point B is y1. And the slope of a straight line is equal to the tangent of the angle that it creates with the positive side of x-axis. This is actually the angle of the straight line creates with the positive side of x-axis. This is of course a right angle because x-axis is perpendicular to y-axis and therefore this is a right angle. This diagonal bisects the right angle according to the rule that the diagonals of a square bisects the angles of the square. This diagonal of this square bisects this angle. The first half is 45 degrees and the second half is also 45 degrees. So in total the side of this angle, that is the angle that the straight line creates with the positive side of x-axis, is 45 degrees plus 9 degrees, this is 135 degrees. So the slope of this straight line BO, that is defined as m, the slope of the straight line BO, that is m, equals to tangents 135 degrees, that is the angle that the straight line BO creates with the positive side of x-axis. This is angle. This is the angle. This is 145 degrees. So tangent 145 degrees equals to -1. That is to say, the slope of this straight line BO is -1. And whenever you have a negative slope, it means that the straight line is descending from the left side to the right side. Well, because it has negative slope. If the slope is positive, then it will be rising from the left side to the right side. Okay. Now, point O, the origin, is definitely located on the straight line BO. We know that the slope of this straight line BO is -1. We just trying to find out the slope of the straight line BO is -1. Whenever you have the value of a slope and you have one point that you know the values of x coordinate and y coordinate, then you can definitely find out the equation of this straight line BO. Again, m, the slope m is -1, and point O is located on the straight line BO, and the coordinates of point O are 0, 0. This is the origin. So the equation of any straight line is y minus y1 equals to m times x minus x1. M is the slope, x1 and y1 are the coordinates of the point that is located on the straight line itself. They are the known coordinates. So here point O is located on the straight line BO, and we know that the coordinates of point O, x1 and y1, because x1 is 0, y1 is also 0. And again, point O is located on the straight line BO, and therefore x1 is 0 and y1 is also 0, and m equals to -1. So we just have to put the data of this straight line BO inside this general formula for a straight line. In this way, we find out the equation of this straight line BO. Okay, we have again y minus y1 equals to m times x minus x1. That is the general formula for any straight line. So it is y minus y1, y1 is 0, so it is y minus 0 times m is -1. Inside the brackets we have x minus x1, so it is x minus x1, that is 0, x minus 0. Y minus 0 is y, and it equals to -1 times x minus 0 is x, so that y equals to -1 times x is -x. So we have found out that the equation of this straight line BO is y equals to -x. In the next step, we calculated the slope of this straight line AO. I picked on the definition of a slope. The slope of a straight line measures the steepness and direction of the straight line. Repeat again, the slope of a straight line measures its steepness and direction. And we calculate the value of the slope according to the following formula: m equals to y2 minus y1 over x2 minus x1. y2 minus y1 is the vertical change, and we divide it by x2 minus x1, that is horizontal change. Horizontal change. So, as I mentioned before, if the slope of a straight line is a positive, it means that it goes up from the left side to the right side. Likewise, if a slope of a straight line is negative, it means that it goes down from the left side to the right side. And finally, if the slope of the straight line is 0, it means that it is parallel to the x-axis. And if a slope is perpendicular to x-axis, that is to say it is parallel to y-axis, then it means that the straight line has no slope at all. Really, whenever you have a straight line that is parallel to y-axis, it means that it is not a function at all. We are talking about linear functions, we are talking about straight lines that are functions. If a slope, if a straight line is vertical to y-axis, it means that it is no function. It is no function at all. So therefore, we don't have even to require about the slope because it is no function at all. It means it is not in linear functions. We are talking about straight lines that are functions. Okay. So the slope of this straight line AO will be calculated according to those two known points A and O. And the slope M of this straight line AO equals to y2 minus y1 over x2 minus x1. We find the x coordinate of this point A is x2 and the y coordinate is y2. Likewise, we define the x coordinate of this point O is x1 and the y coordinate is y1. So according to the formula for a slope, the slope of the straight line AO equals to y2 minus y1. y2 is 2 and y1 is 0. So it is 2 minus 0, that is 0, over x2 minus x1. x2 is minus 6, minus x1, that is 0. Minus 6 minus 0 is minus 6. So x2 minus x1 is minus 6 minus 0, that is minus 6. 2 minus 0 is 2, so the slope of the straight line AO equals to 2 minus 6, that is minus third. And again, if you found out that the slope of the straight line AO is minus third, you can see that it descends from the left side to the right side because of the fact that the slope of this straight line is a negative. We know that the straight line AB is perpendicular to the straight line AO. And their intersection points that create 90 degrees and therefore they are perpendicular to each other. Whenever you have two perpendicular straight lines, you can implement rule 12. So I'm speaking on rule 12. According to rule 12, if two lines intersect with each other at 90 degrees, and we know that the slope of the straight line is m1, the slope of this straight line is m1, and the slope of the second straight line is m2, the slope of this straight line is m2, then the following equation is to m1 times m2 equals to minus 1. So the product of those two slopes equals to minus 1. So whenever you have two perpendicular straight lines, then the products of their slope must be equal to 1. You can definitely implement rule 12 in our drawing. Why? Because of the fact that the straight line AB is perpendicular to the straight line the straight line AO is perpendicular to the straight line AB. This is the right angle. Therefore, the slope of those two straight lines must be equal to -1 according to rule 12. We already found out that the slope, we just found out that the slope of the straight line AO is -3. We don't know what is the slope of this straight line AB, so we define it as M2. So according to equation to rule 12, M2 times 1/3, that is the product of the slopes of those two perpendicular straight lines, must be equal to -1. And again, according to rule 12, the product of the slope of the straight line, the product of the slopes is -3 times M2. It must be equal to -1 according to rule 12. If we multiply this equation by -1, so minus times minus is plus, so in this the equation we have M2 over 3, and this equals to -1 times -1 is 1. You multiply this equation by 3, we know that M2 equals to 3. That is to say, the slope of this straight line AB equals to 3. This is point B. That is a common point that belongs to both straight lines. Point B is definitely located on the straight line AB, and point B is definitely located on the straight line BO. And we have the rule that says that if a point is located on the straight line, then it must satisfy the equation of the straight line. Again, if a point is located on a straight line, then it must satisfy the equation of the straight line. So point B is located on this straight line AB, therefore it must satisfy this equation. But before that, we have to find out the equation of the straight line AB. We already found out that the slope of this straight line AB is 3, and point A is definitely located on the straight line AB. Whenever you have the value of the slope and one point on the straight line, then you can easily find out the equation of the straight line. Point O equals to the coordinates of point A is -6 and 2, and the slope of the straight line AB is 3. You can easily find out the equation of the straight line AB. According to the formula that I already presented to you a couple of times, that said that the equation of any straight line equals to y1 minus y1 equals to m times x minus x1. So the slope of the straight line AB is 3, so m equals to 3. This is point A, we know that's the coordinates of point A. Therefore x1 will be equal to -6 and y1 equals to 2. And again, x1 equals to -6 and y1 equals to 2. We just have to put the data of this line AB inside this general formula for a straight line, and this way we find out the equation of this straight line AB. So y minus y1, y minus y1, y1 is 2, so it is y minus 2 equals to m. m is 3, and inside the brackets we have x minus x1. So it is x minus x1. x1 is minus 6, therefore x minus x1 is x minus 6 minus 6, that is plus 6, x plus 6. So in total, we found out that y minus 2 equals to 3 times x plus 6. Here we open the brackets on this side of this equation, and we found out that y minus 2 equals to 3x plus 3 times 6, that is 18. So in total, y minus 2 equals to 3x plus 18. Here we added 2 to this equation, and we found out that y equals to 3x and 18 plus 2 is 20. So y equals to 3x plus 20. So we found out that the equation of this straight line AB is y equals to 3x plus 20. We already found out that the equation of the straight line BO is y equals to minus x. By the way, you can see that the slope of this straight line is a positive, and therefore it rises from the left side to the right side. Why? Because the slope is a positive. And the slope of this straight line is negative, therefore it descends from the left side to the right side. Okay. So we have the equations of those two straight lines, and point B is a common point that belongs to both straight lines. As I already mentioned before, if a point is located on a straight line, then it must satisfy the equation of the straight line. Okay, again, if a point is located on the straight line, then it must satisfy the equation of the straight line. Point B is located on the straight line AB, therefore it must satisfy the equation of this straight line AB. This is y equals to 3x plus 20. That is to say, the coordinates of point B are x1 and y1. So if we substitute x by x1 in this equation and y by y1, we get that the left side of the equation equals to the right side of the equation. Likewise, point B is located on the straight line BO. Therefore, point B must satisfy the equation of this straight line BO, that is y equals to minus x. That is to say, if you substitute x by x1 and y by y1, we get that the left side of the equation equals to the right side of the equation. So we have point B satisfied this equation of the straight line AB. So we substitute y by y1 and x by x1, and found out that according to equation 1, y1 equals to 3x1, y1 equals to 3x1 plus 20. Okay. Likewise, point B is located on the straight line BO, therefore it must satisfy this straight line BO. That is to say, y1 equals to minus x1. So according to equation 2, we found out that y1 equals to minus x1. So we have two equations for y1. Therefore, created equation 3 that said that y1 according to equation 1 must be equal to y1 according to equation 2. y1 according to equation 1 equals to 3x plus 20. And it must be equal to y1 according to equation 2. y1 according to equation 2 equals to minus x1. So total according to equation 3, we found out that 3 times x1 plus 20 equals to minus x1. Here we added x1 to the equation, and we found out that 4x1 plus 20 equals to 0. And again, according to equation 3, we found out that 3x1 plus 20 equals to 3x1 plus x1 is 4x1 plus 20 equals to 0. Here we subtract 20 from this equation, and we found out that 4x1 equals to minus 20. Here we divide this equation by 4, and we found out that x1 equals to minus 20 over 4 is minus 5. That is to say, we found out that the coordinate x of point B, x1 equals to minus 5, and the coordinate y, according to equation 1, y1 equals to minus x1. Okay, so y1 equals to minus x1, and x1 is minus 5, so y1 equals to minus 5. Minus 5 is plus 5. So in total, we should find out that y1 equals to 5. That is to say, the coordinate b of this, the coordinate y of this point b is 5. So in total, point b is minus 5. The two coordinates of point b are minus 5 and 5. In the next step, because of the fact that we know that values of those 3 points A, B, and O, we can definitely find out the distance between points A and B. The distance between points A and B is the length of side AB. The distance between points A and O is the length of side AO of this entire AOB. So we have what is the formula for distance between two straight lines? The distance between 2 points. Here we have the green line PQR. We know that the coordinates of point Q is x2 and y2, and the coordinates of point P is x1, y1. And our task is to find out the distance between points Q and P. So in order to find, what is the distance between points Q and P? It is the length of the hypotenuse QP. In the right triangle PQR. And according to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So this right triangle PQR, PQ square, that is the square of the hypotenuse, equals to QR square plus PR square. Again, according to the Pythagoras theorem, this right triangle PQR, PQ square, that is the square of the hypotenuse, equals to PR square plus QR square. PQ is the missing hypotenuse, so leave it as it is, and it equals to PR square. PR equals to x2 minus x1, therefore PR square equals to x2 minus x1 square, plus QR square. QR equals to y2 minus y1, therefore QR square equals to y2 minus y1 square. So in total, we should know that PQ square equals to x2 minus x1 square plus y2 minus y1 square. If we took out of the equation, we found out that the length of the hypotenuse PQ, that is also the distance between those 2 points P and Q, is equals to the square root of x2 minus x1 square plus y2 minus y1 square. And because of the fact that points Q and P could be any points, this is the formula for the distance between two any points. So we use the new formula in order to find out the distance between points A and B and the distance between points A and O in our drawing. We have to find out the distance between points A and B. And we have the formula that says that the distance between any 2 points equals to the square root of x2 minus x1 square plus y2 minus y1 square. So the distance of those between those 2 points A and B will be equal to x2 minus x1 square. x2 is minus 5, minus x1 is minus 6, so minus 5 minus 6 is minus 5 plus 6, that is 1, and 1 square is 1. So in total, if you found out that x2 minus x1 square equals to 1, likewise we have y2 minus y1 square. y2 is 5, minus y1 is 2, so 5 minus 2 is 3, and 3 squared is 9. So we should all know that y2 minus y1 squared equals to 9. So inside the root we have 1 plus 9 that is 10, so AB equals to the square of 10 units in itself. The distance between points A and B is also the length of side AB, and the length of side AB in total is equal to the square root of 10 units in itself. Likewise, we calculated the distance between points A and O. That is actually also the length of side AO of the entire ABO. The distance between those 2 points A and O, according to the formula, is equal to x, the square root of x2 minus x1 square plus y2 minus y1 square. So we choose the coordinates of point A is x2 and y2. We choose the coordinates of point O as x2 and x1 and y1. So according to the formula, AO equals to the square root of x2 minus x1 square. So it is x2, that is actually minus 6 minus 0 square. Minus 6 minus 0 is minus 6, and minus 6 square is 36. So we should know that x2 minus x1 square equals to 36. We have also plus y2 minus y1 square. y2 is 2, minus y1 is 0, 2 minus 0 is 2, and 2 squared is 4. So we should know that y2 minus y1 squared equals to 4. So in total, inside the root, the root we have 36 plus 4, that is 40. So in total, we should know that the length of side AO is equal to 40 units. The square root of 40 units in its length. AO equals to the square root of 40 units in its length. And AB equals to the square root of 10 units in its length. Our task is to find out the area of this green shape. The green shape is actually the green right triangle ABO. So our task is to find out the area of this green right triangle ABO. And again, because of the fact that the green shape is actually the green right triangle BAO, our task is to find out the area of the green right triangle BAO. And the area of any triangle equals to the base of the triangle times the height to the base over 2. We choose the base as BAB and the height as AO. Again, the base is AB and the height is AO over 2. AB is square root of 10, AO is square root of 40 over 2. Square root of 10 times square root of 40 is square root of 400 over 2. Square root of 400 is 20, and 20 over 2 is 10. So in total, we found out that the area that we are looking for in this question, that is the area of this green shape, equals to 10 square units in size. So we finish to repeat on the first method. In the next step, repeat on the solution according to the second method to find out the area of this green rectangle ABO. So we know that we have 3 identical squares. One side of this square is 2, therefore all the sides of all the squares must be equal to 2. Okay, and we actually created here a rectangle by extending those 2 sides. But here we have those 2 angles are right angles because those 2 shapes are squares, and those 2 angles are also right angles because of the same reason. So in total, this quadrangle EG, this quadrangle EGCD, we have 4 angles, and therefore equivalent to this quadrangle EGCD is a rectangle. But we also know that the opposite sides of a rectangle are parallel to each other. So in rectangle EGCD, ED is parallel to the opposite side CG. And when you extend two parallel lines by side line, the result must be also two parallel lines. This is to say, AD must be also parallel to BC. Okay, so AD is parallel to BC. In the next step, we did a construction. This is to say, we constructed a perpendicular on AD in such a way that it will pass for point F, that is the vertex of this green rectangle EFC. Here, we created a group perpendicular on side AD in such a way that it will pass for point F. So this angle equals to 90 degrees according to our construction. So in the big quadrilateral ABCD, we have 1, 2, 3 rectangles, and therefore this fourth angle must be equal to 90 degrees inside, according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. The second reason that this fourth angle must be equal to 90 degrees inside is as follows. We know that AD is parallel to BC, and this angle equals to 90 degrees inside according to our construction. Those two angles are defined as one-sided interangles and are located between the parallel lines AD and BC, and therefore must be equal to 180 degrees according to the rule that said that the sum of two one-sided interangles that are located between parallel lines must be equal to 180 degrees. But this angle equals to 90 degrees, and therefore this missing angle must be also equal to 90 degrees in size. So I presented two results that this fourth angle must be equal to 90 degrees in size. So in the big quadrilateral ABCD we have 4 angles, and therefore generate to big quadrilateral ABCD is a rectangle. Okay, so the big quadrilateral ABCD is a rectangle. Okay. AD is one side of rectangle ABCD, therefore it is absolute a straight line. So if we focus on the right side of the straight line AD, it's point E, if the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 said that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the right side of the straight line AD is point E? First of all, we define this angle as alpha. So in the right side of the straight line AD is point E, we have this is angle alpha according to our definition. This is a right angle according to what is going to the question. Plus this third angle, so that the sum of those angles must be equal to 180 degrees according to rule 3. So repeat again, if we focus on the right side of the straight line AO at point E, the sum of the angles must be equal to 180 degrees. That is to say, angle alpha plus 90 degrees plus the third missing angle AEF in total must be equal to 180 degrees according to rule 3. If subtracted 90 degrees from this equation, if I found out that alpha plus the missing angle AEF must be equal to 90 degrees, because 180 degrees plus 90 degrees is 90 degrees. If subtracted alpha from this equation, if I found out that the third missing angle AEF equals to 90 degrees minus alpha. This is the third missing angle AEF, this is equal to 90 degrees minus alpha. So in this right line AEF, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees, and therefore this angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. It is the sum of the angles in any triangle. Likewise, in this lower right triangle triangle ADC, this angle equals to alpha. This angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha. According to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we prove that those two right triangles are similar to each other according to angle similar to. So why those two right triangles are similar to each other? First of all, those two angles are both equal to alpha, and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees oneself and therefore they are equal to each other. So she found out that all the figures of this right upper triangle AFA corresponding equal to all the figures of this right lower triangle EDC. Therefore, those two right triangles are congruent to each other, are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. Here again, we should find out that the upper right triangle AF is similar to the lower right triangle EDC according to angle similarity rule. And from the fact that sine AF is similar to the right triangle EDC, we derive that the following relationship exists between their sides. We derive that side AE of this right triangle AEF or side DC of this right triangle EDC equals to side AF of this upper right triangle AFE or side ED of this right triangle EDC. And again, from the fact that those two right triangles are similar to each other, we derive that side AE of the upper right triangle AFE or side DC of the right triangle EDC equals to side AF of the upper right triangle AFE or side ED of the right lower triangle EDC. AE is the missing side, so it is DC6, AF is the missing side, and AD is 2. So in total, we shall know that AE over 6 equals to AF over 2. A of course multiplies the equation, and we found out that two times A equals to 6 times AF. Here we divided the equation by 2 and we found out that 2A over 2 is AE and 6 AF over 2 is 3 AF. So in total we found out that A equals to 3 AF. So if we define AF as X, then AE must be equal to 3X. So this is the equation. So actually defined AF as X, and therefore AE must be equal to 3X. Okay. We already found out that the big quadrangle ABCD is a rectangle. But we also know that the opposite sides of rectangle are equal to each other. So in the big rectangle ABCD, side AB must be equal to the opposite side DC. The big rectangle ABCD, side AB must be equal to the opposite side DC. But this in total is 2 plus 2 plus 2 to the 6, therefore the opposite side AB must be also equal to 6 units in itself. So we derive that from this equation that AB must be also equal to 6 units in itself. AB equals to 6. What is the ref of FE? From the moment it is very easy to see that FE in total equals to AB minus AF. FB equals to FB equals to AB minus AF. So AB equals to AB, that is 6, minus AF, that is X. So in total, EB, that is inside EB, equals to 6 minus X units. Likewise, according to the sum rule, in the sum of triangle ABCD, side AD must be equal to the opposite side BC. But AD in total equals to 3x plus 2, therefore the opposite side BC must be also equal to 3x plus 2 in itself. So the opposite side BC must be also equal to 3x plus 2 units in itself. In this square, the diagonal bisects this angle of this square. Each half must be equal to 45 degrees. So in the big triangle AFBC, This angle equals to 45 degrees. This angle equals to 9 degrees. 45 degrees plus 9 degrees, it is 135 degrees. So 135 degrees plus this third missing angle, in total must be equal to 180 degrees. According to the rule, just said that the sum of the angles in a triangle is equal to 180 degrees. Therefore, this third missing angle must be equal to 45 degrees in size. So in this triangle FBC, we have the rule that said that the front of equal angles in the triangles, they are equal size. So in this triangle FBC, in front of those two equal angles, we have those two sides that must be also equal to each other and the length. That is to say FB equals to BC. Triangle FBC, FB equals to BC. Again, in triangle FBC, FB equals to BC. But we only found out that FB equals to 616. So we can write that FB equals to 616, and from this equation 616 equals to FB equals to BC, we know that BC must be also equal to 616 in its length. So BC from one side equals to 616. But we only found out that BC also equals to 3x plus 2. So from this equation, 3x plus 2 equals to BC equals to x from 6. We know that those two sides are equal to each other. That is to say, 3x plus 2 equals to 6 from 6. So here we have that x to the equation, and we found out that 3x plus x is 4x, plus 2 equals to 6. Here we subtracted 2 from this equation, and finally found out that 4x equals to 6 minus 2 is 4. So 4x equals to 4. Here we divide this equation by 4, and finally found out that x equals to 1. AF equals to x and x equals to 1. A equals to 3x, and therefore A equals to 3x times x is 1. So 3x is 3 times 1, that is 3. So in total, A equals to 3 and AF equals to 1. In the next step, we present the Pythagoras theorem on this right triangle AFE. This right triangle AFE, according to the Pythagoras theorem, FE squared equals to AF squared plus AE squared. So FE squared equals to AE squared. A is 1, so A squared is 1 squared, that is 1, plus AE squared. A is 3, so A squared is 3 squared. So in other words, we all know that FE squared equals to 1 plus 9. So if you found out that FAE, FE squared equals to 1 plus 9, that is 10. So you have to go out all those equations. If I found out that FE, so in total, if you found out that FE equals to 10, you have to go out all this equation. If I found out that FE equals to the square root of 10 units in its length. Therefore, FE equals to the square root of 10 units in its length. Likewise, we implemented the Pythagoras theorem on this right triangle EDC. This right triangle EDC, according to the Pythagoras theorem, EC squared, that is the square of the opponent, equals to ED squared. ED is 2, therefore ED squared is 2 squared, that is 4, plus DC squared. DC is 6, therefore DC squared is 6 squared, that is 36. So in total, we found out that in the right triangle EDC, EC squared equals to 4 plus 36, that is 40. So EC squared equals to 40. Here we have to go out this equation, if I found out that EC equals to the square root of 40 units in its length. This is side EC, is equals to the square root of 40 units in its length. Our task is to find out the area of this green shape. The green shape is actually the green right triangle EFC, so our task is to find out the area of this green right triangle EFC. So the green shape is the green right triangle FEC, therefore our task is to find out the area of this green right triangle FEC. Actually, we know that the area of any triangle equals to the base of the triangle times the height over 2. We choose the base as FE and the height is EC. And the base is FE and the height is BC divided by 2. We already found out that FE equals to the square root of 10 and EC equals to the square root of 40, the square root of 40 over 2. The square root of 10 times the square root of 40 is the square root of 400 over 2. The square root of 400 is 20, and 20 over 2 is 10. So in both methods, we can find out that the area that we are looking for in this equation, that the area of this green shape, is equal to 10 square units in size. Okay, thank you very much.